All right, so now we're asked to find the probability that the mean weight of the 9 babies, so mean weight of the 9 babies, that's a value of x bar. Probability, that is our p parentheses. So we want the probability that the mean weight of the 9 boy babies born was less than 3,500.4 grams. Okay, so here we've just translated all of the words back into mathematical symbols. So again, keeping in mind our random variable x bar is the mean weight of 9 randomly selected baby boys, and we're looking now for the probability that x bar is less than 3,500.4 grams. Again, we know x bar has a normal distribution, so we can use normal CDF on the calculator to get that. So on the calculator, to get the probability that x bar is less than 3,500.4, we would use normal CDF to get a probability. Okay. Again, from our graph here, we can see that, again, remember normal curves start out here at negative infinity, which we're going to use negative 10 to the 99 for that endpoint, up to 3,500.4. And then we need the mean of the distribution, which was 3687.6. And then for the standard deviation, we're going to put in there 410.5 divided by the square root of 9. Again, this is the step where this is changed from section 6.3, and we're going to type that radical right in that input piece on the calculator. Okay, so if we input that, we're going to get an output of about 0.086. So again, keep in mind that is the area of this shaded region here. So again, continuous x bar is again a continuous random variable, and so probabilities are going to correspond to area under the curve. Okay, so the area of the shaded region is about 0.086. Okay. So if we interpret what this means in the context of the problem, that tells us there is about an 8.6% chance that the mean birth weight of 9 randomly selected boy babies of European descent. All right, so there's about an 8.6% chance that the mean birth weight of 9 randomly selected boy babies of European descent, that is less than 3,500.4 grams. Okay. And in this case, again, just keeping in mind as we go forward with inferences, we're going to be interested in whether we have not so unusual or unusual results. Okay, so this is more than 5%. So not so unusual for this to have happened. Right, part G asks us to find the probability that the mean weight of the 9 babies was less than 3,452.5. So in this case, we're looking for the probability of getting an x bar to the left of 3452.5. So again, we can see from the shading on our graph that that's going to start again at negative infinity. So this is going to be equal to normal CDF, negative 10 up arrow 99 to 3,452.5. And then our mean is still 3,687.6. And the standard deviation is still 410.5 over the square root of 9. Again, if we input that to the calculator, we will get roughly 0.043. So again, keep in mind that that probability represents the shaded area that is here. So if we interpret this that means there is about a 4.3% chance of getting a mean birth weight of 9 randomly selected boy babies of European descent to be less than 3,452.5 grams. Now that is less than 5%, so this is unusual. So again, it's still pushing us a little bit forward to inferences, but when we see unusual events, we tend to go back and then think about some claim about the distribution and its parameters not being correct. So if this actually happened, if we actually took a random sample of 9 boy babies and got a mean birth weight as low as 3,452.5 grams, you may think that there's something unusual about this sample. Okay, maybe some of the 9 babies were born as multiples, okay, which brings the mean weight down, or maybe some or all of the babies were not of European descent. Okay, so again, different nationalities, their babies are different weights, so the mean weight of South Asian boy babies is 3,452.5, so the number that we're looking at. Or it could be that we're seeing evidence that the mean weight of all baby boys of European descent is now lower than what they claimed. And we're saying lower because we saw an unusually low value. Okay, we computed an area in the left tail, the lower tail. We got a probability less than 5%. So when we see an unusually low value, it leads us to believe that the parameter value they gave us might not be correct. It might actually now be lower than that.